All right, in this video, let's take a look at what's happening with induction by grounding and induction with separation or by separation. And let's look through the stages. So the key about induction and what's special about this is that there's no contact directly with the object that you're charging. And so you can do it strictly through polarization and taking advantage of some of the properties of some conductors. So what is charging by induction with grounding? First of all, it works for conductors only. It won't work for insulators. So this is what we did with the mini Death Stars. So let me take mini Death Star, and originally it's neutral, meaning equal numbers of positive and negative charges. And I'm going to bring a negatively charged, now let's get some colors in here. We'll go blue for negative. A net negative charged object near this neutral conductor. Well, what's going to happen? Well, we know that the first step is that the conductor is going to polarize. Polarization means separation of charges. So therefore, since negative charges are free to move inside a conductor, they are going to gather as far away from the existing negative charges as possible. They will repel to the other side. Now, it's not that they're all going to migrate there, not all the electrons end up there, but a net flux of electrons shifts to the right to try to avoid this series of electrons over here due to the repelling electric force between them. Well, what happens when a net shifting of negatives goes to the right? I leave the right-hand side, or the left-hand side, excuse me, exposed as positive. So I've polarized the conductor. Now, stage 2. Now we take the neutral conductor, still neutral, and we ground it. You did this in the lab with your finger. Now the charged object is still held nearby, and you have to hold it nearby, because if you remove this negative charge, everything's going to redistribute, and it's going to go back to just normal neutral, not polarized neutral. So when you leave the negative charge here, this leaves the conductor as polarized, and it allows this excess of electrons. Remember, like charges repel each other, and this object on the right-hand side wants to be neutralized. So it's going to want to easily give those extra electrons to ground. So I'm going to ground by losing electrons in this case. And so that this side basically takes some electrons away. Well, I'm still left with a net positive charge. So the effect of induction by grounding is that whatever charge is left on this side then distributes about the conductor. Now, let me explain what happens. Remember, positive charges remain in place. So what's going to happen is the electrons will be distributed along and among the positive charged nuclei so that it leaves the exterior surface as a net positive charge. So the net charge always resides on the surface of the conductor based on the way in which the internal electrons distribute themselves between the atoms there. So this is charging with grounding. I bring a charge nearby, polarize, ground one side, and then I'm left with a conductor that's either positively or negatively charged. Now, induction with separation is very similar, except this time, instead of grounding, I start off with two conductors that are in contact with one another. And I'm going to do the same thing. I'm going to bring a negative charge. It could be positive. Let's do negative again, so for similarity's sake. But this time, because the conductors are touching and making contact, my negative charges that kind of push towards the right-hand side will separate amongst the two different spheres. So I'm basically like polarizing these two conductors as one big conductor since they're in contact with one another. Now notice they are on insulated bases, so they don't discharge to the ground or the surface they're resting on. Now, what am I going to do? While I've held this still in place, I'm going to now separate the two charges by moving the base. So now, I still have this negative rod over here. Let's just leave this here for now. Oh, I'm losing some sequins off my fancy gloves. So what happens? The one that I pulled off to the side, this had a net negative charge when they were in contact. So now it's stuck with a net negative charge now that they're out of contact. And this one is stuck with a net positive charge, right? Because now they're separated. So what happens when I remove this? I am left with two separately charged, isolated conductors. The one on the right, in this case, being negative. The one on the left being positive. So the net result of induction is that I'm left with a charged conductor, or two charged conductors in the case of induction with separation. Now, we said what's special about this is that there's no direct contact, no direct transfer of electrons. The only direct transfer of electrons occurs when you ground the one side. So during this process, there's always polarization. So what is an example of this from class? Well, one of the examples of charging by induction was when we did the mini Death Stars in the lab. And the way you could test it is that once you charge this positive, if you have the positive sphere, which what you guys had when you did the message of charging lab, excuse me, when you touch it again, you ground it, you get a shock. What you do there is you give electrons back to the conductor so that it goes from positive to back to neutral. And then it won't shock you. So you got a little shock both when you took the electrons away and when you gave them back. And that's one of the examples that we did in class.